All right.
Oxygen has 8.
Oxygen has 6.
Oh, it does?
Has 8 total electrons, but oxygen's valence electrons are 6. 1, 2, 3, 4, 5, 6. Okay, so I want 6 dots around the oxygen, but carbon has just 4 valence electrons. 1, 2, 3, 4. Okay, so we're going to use this arrangement here to get to our first example of double bonding. Okay, if I'm trying to arrange electrons in such a way that the hydrogens get the 2 electrons they want to have a full valence level, and the carbon and oxygen get to the number of electrons they want to have a full level, hydrogens want 2, and carbon and oxygen want 8 altogether. Okay? Yes.
This is covalent bonding, right?
This is all still covalent bonding. Okay?
How do you do it?
All right, tell me how to do it.
You add the carbon to the oxygen,
Okay?
and you do another one with the carbon, right?
To what?
2 bottom.
Okay. So you're going to put share 2 sets of or 2 pairs of electrons with the oxygen.
And then do the hydrogen, yeah.
Okay. Everybody get that? Good prediction. All right. Then if we're going to go from there to our Lewis dot formula like we did here with ammonia, we get, let's put the hydrogen over the carbon here and out here. But then for the 4 electrons that are shared between carbon and oxygen, we're going to write our Lewis dot formula like this. Okay, there's our 4 shared electrons between carbon and oxygen. Okay? They're not 4 completely vertical, okay, or side to side horizontal. They're kind of the 4 corners of a square. Okay? But now, this bond doesn't look anything like this. All right? This is a sort of bookkeeping system where the guy who invented this came up with a way to kind of keep up with where the electrons are going and where they're pairing, but it's not how they actually appear in space if we were able to see bonds, the actual bonds. So what we're going to do is you do balloon models so we can actually see how that happens. Now I want to do a drawing for you first because I want to explain how this double bond here, this is called a double bond. It's a double bond in there. Okay? A double bond has 2 different kinds of bonds. A double bond has 2 different kinds of bonds. It has the sigma bond we've already learned about, and it has a pi bond we're about to learn about. Okay? You got both. So here's our carbon atom right here, and here's our oxygen atom. Okay? Now, there is a bond directly on a line between the nuclei of carbon and oxygen. By definition, we said that any bond directly on a line between the nuclei of 2 atoms is called a, what kind of bond? Sigma bond. That's the definition of a sigma bond. So if I have a bond directly on a line between these 2 nuclei here, that's a sigma bond.
I'm writing this in my lab notebook. I just noticed.
Well, that's okay. You need to have it someplace, but this is all kind of part of the lab.
Okay.
All right? That's a sigma bond. Okay? But if you'll remember, the reason why electrons form this hybridization and why they form the unhybridized state is because pairs of electrons can be close. Two electrons can get close together by having opposite spins, but that's all you can do. After that, the 2 pairs, or if you have more than 1 pair, they want to separate themselves. That's why we have these orbital shapes, okay? Because the electrons can't be close together once they paired up. 1 pair can't be close to another pair, okay? So we need a second bond between carbon and oxygen that does not occupy this same space. Are you with me? We can't occupy the same space because 2 pairs can't be in the same space. So we need an arrangement that's going to get that second pair away from the first. So here's what I want to do. I want you to remember, we're starting with are these p orbitals. Remember these p orbitals? We did that in the last unit. Okay? So this is an unhybridized set of p orbitals. And remember we had to hybridize all these orbitals, right? We had to hybridize to get there. But with this bonding, we're going to have a p orbital that does not hybridize. And the p orbitals, remember there's two nodes to a p orbital? They're going to reach out and touch each other like this. So the two nodes of the p orbitals become two nodes of a pi bond. The two nodes of a p orbital become two nodes of a pi bond. Now, that's a little bit kind of complex. Let's make this a little bit simpler drawing here, okay? It's kind of the same thing, but instead of having all that stuff in there, I'm going to simplify the drawing of the p orbital, okay? I mean the pi bond, which comes from p orbitals. Okay? So those are two nodes of the same pi bond. All right? So this is pi. All right? Okay. Now the lone pairs out here on oxygen, here's a little trick for you. I guess it's a trick. Something to remember that will help you. Lone pairs of electrons always form hybridized ED orbitals. And what was the shape of a hybridized orbital? A balloon shape. Now, three-dimensionally, this is a little bit tricky because what I have is a 1, 2, 3 things vertically. So to get the two balloons as far apart from all these electrons as I can get them, I need to have one balloon swinging out toward you and one balloon swinging back behind the paper. Okay? So we're going to have a balloon that's coming out toward you like this. And then I want to have a balloon that's swinging back behind the paper. Okay? Likewise, to get bonds here between the hydrogen and carbon as far apart as I can get them, I need to have one swinging out toward you, okay, and one swinging back behind the paper. I'm running out of colors here. Well, I'm going to have to double up on colors just because I need more colors.
Right.
Oh, gracious, who did that?
Hey. Yeah, you got some blood.
Okay, there's one bond swinging out toward you. So that's a long balloon that's kind of swinging out toward you. If anybody who's had artwork knows what perspective is, it's coming out toward you. And then we're going to have one going back behind there. Oh, I got this color here I can use. Okay, so I can make this color like this. Oh yeah, you can. Oh yeah, you can. Yes, you are.
We are?
Mm-hmm. And this is directly on a line between the two nuclei. So this is pi. I mean, this is sigma. And this is sigma. And this is a hydrogen out here. Okay? Now, the hybridization of the carbon and the oxygen are not sp3. The hybridization of the carbon and the oxygen are not sp3. Okay, so each carbon and each oxygen have to have a p orbital that we did not hybridize. Remember? Well, that should be an oxygen over here. I made a carbon for some reason. Okay? All right. This oxygen over here had a hybridized orbital here because lone pairs are always hybrids. Oh, sorry. And the sigma bonds also always come from hybridized orbitals. So they were, the way we think about it is they started out like this, and then they sort of overlapped and joined up. And these two sigma bonds then over here are going to be starting out as hybrid orbitals. Okay? That's how we started out, and then we started joining everything up.
So we're making the top one?
You're making the top one. I just need you to know this. Okay? So let's do a little bit of quick lesson on how to make the top, bottom, and the bottom in the middle. You got this? All right. You're going to need 3 long balloons. Now, those of you who don't have these really long balloons like I've got here, you're going to have to kind of double up on some balloons to make this work. Okay, I need 3 long balloons, and notice that I had to throw one out here a while ago. Got a bump on my floor there. Okay. Notice what I've already done to this. I've tied a knot in the end. Okay? You're going to take your 3 long balloons and leave yourself about an inch or couple of 2.5, 3 centimeters. I should say centimeters to the inches, right? I'm in a science class. Okay? Tie a knot about right there because you need this to make knots with. Alright? Okay. So let's say here's our bond that goes across here. I need to have the tip of this balloon, this sigma bond here, tied to two round balloons. Okay? Then I will make about an 8-inch or 9-inch long balloon and tie a knot right there that I will then make bonds to here with. Okay? What? Okay. So, you're going to need two round balloons here, a long balloon that's going to make this whole loop, a long balloon to go here, and 2 more long balloons. Okay? Now, let's put you guys in groups of 3, because this is kind of complex. You want to choose? Yes. You want to choose your own groups? If you don't finish before class is over, you got to do it at home. Do you want to do it in class? All right. Let's do it in class. Do you want to group yourselves up, or do you want me to group you? All right. Group yourselves in. You're going to need.
So we're going to make one model for each group?
You're going to need 2 round balloons, 1, 2, 3 long balloons with knots in the end to start with. Okay?